All right, so ever feel like you're just drowning in AI research?
Yeah,
Like there's just so much out there.
yeah, definitely.
Well, today we're taking a deep dive into a paper that's really making waves.
Huh?
Hymba, a hybrid head architecture for small language models.
Sounds pretty complex.
It is, but don't worry, we'll break it down.
Okay.
This paper is hot off the press from NVIDIA and Georgia Tech.
Nice.
And it's all about making powerful AI way more accessible.
That's really the key, isn't it? Like
Yeah.
large language models, LLMs,
Yeah.
they're amazing,
Yeah.
but they just need so much power.
And memory.
Yeah, exactly. So
Yeah.
Hymba,
Yeah.
it's offering this really kind of revolutionary hybrid approach.
Okay, so.
It combines the strengths of transformers and SSMs.
Okay, so break that down for me.
Sure.
We've got these two kind of key players,
Yeah.
transformers and SSMs.
Right. So think of transformers like the memory whizzes
Uh-huh.
of the AI world.
Okay.
They're really good at remembering long strings of information.
Like remembering every word in a book.
Exactly.
Wow.
And then you've got SSMs, and they are incredibly efficient at summarizing.
Okay.
It's like reading a whole book
Yeah.
and condensing it down to the key takeaways.
Oh, that's pretty
Yeah,
cool.
it is.
So it's like having two specialized brains working together.
That's a great way to put it.
One for details, one for the big picture.
Yeah, and what's really cool is
Yeah.
Hymba doesn't just stack these two approaches
Oh,
like some previous models did.
right.
It blends them within the same layer,
Okay.
so they're working in sync.
So they're not just teammates. They're like
Correct.
a perfectly synchronized
Yeah.
pair of dancers.
I like that.
And the paper actually compares this to human memory,
Oh, wow.
with attention heads being like our snapshot memories,
Oh, that's fascinating.
and SSM heads acting as our fading memories.
Oh, that's a great analogy.
Yeah.
That balance is really crucial.
Yeah, why is that all right?
Well, because Hymba can use SSMs to offload that broader context
Okay.
so that the attention heads
Yeah.
can zero in on the really important details.
So it's all about...
It's all about allocating those memory resources really strategically.
Okay, but hold on. There's more to this, right?
It is.
They've also got these things called meta tokens,
Right.
which sound like something straight out of a video game.
Yeah, they're pretty ingenious, actually.
Okay.
Think of meta tokens like giving the LLM a cheat sheet.
Before a test.
Yeah, exactly.
Okay.
They're these little snippets of information that are added to the beginning
Uh-huh.
of the input text.
Oh, so it's like preloading the model
Yeah.
with some helpful context
Precisely.
before it even starts processing the main input.
That's right.
Wow. And the researchers actually believe
Yeah.
that these meta tokens
Mhm.
might be encapsulating
Yeah.
a compressed form of world knowledge.
Right. Imagine the possibilities.
Whoa.
If we could preload LLMs with the basic understanding of the world.
Before they even start learning.
Exactly.
So it's not just crunching words in a vacuum.
No.
It's coming in with some pre-existing knowledge.
Yeah, that's right.
Now, the paper has this really cool visualization.
Oh, yeah.
Figure 7, I think it is.
Uh-huh.
And it shows how Hymba's attention is way more balanced
It is.
compared to a traditional LLM.
Right.
Like Llama 3.23b.
Yeah, that visualization really drives home the point.
What do you mean?
You can see that Llama
Yeah.
tends to get bogged down by less important tokens,
Okay.
while Hymba,
Yeah.
it distributes its attention much more effectively.
And that's because of...
It's because of the hybrid approach
Right.
and those clever meta tokens.
Okay, so all this fancy design
Yeah.
isn't just theoretical.
No, it's not.
It actually translates to...
It translates to real-world performance games.
Oh, it's not just a...
It's not just a one-trick pony.
Right.
It can handle a variety of challenges across different domains.
Okay, I'm looking at the comparison chart here.
Okay.
Figure 2...
And it's mind-blowing.
It is.
We're talking Hymba 1.5b beating out models
Yeah.
twice its size and accuracy.
That's a huge leap in efficiency.
That's huge.
It is.
So-
And this work has the potential to democratize access to powerful AI,
Yeah.
bringing it to devices we use every day
Right.
and unlocking possibilities we haven't even begun to imagine.
That's pretty cool.
It is.
So, okay, I'm trying to wrap my head around the implications here.
Yeah.
If we can run these powerful AI models on everyday devices,
Right.
that opens up a whole new world, doesn't it?
It does, absolutely.
Imagine sophisticated language models on your phone
Yeah.
or even smaller devices.
That's right.
No more waiting for things to load.
Yeah.
AI that feels instant as our own thoughts.
That's the vision.
That's incredible.
And that's why this focus on small language models is so important.
yeah.
It's not just about shrinking existing models.
Right.
It's about designing them from the ground up for efficiency. Right, because trying to squeeze a giant model onto a tiny device is like
I know that.
Trying to fit an elephant into a Mini Cooper.
Exactly. You need a whole different approach.
Not practical.
And that's what Hymba demonstrates.
Yeah.
That hybrid approach, those meta tokens.
Right.
It's all about creating AI that's powerful and adaptable.
Okay, so we've talked about efficiency,
Yeah.
but what about performance?
Right.
You mentioned state-of-the-art results.
I did.
What does that actually mean? Like, what kind of tasks
Yeah.
are these Hymba models excelling at?
The paper tested Hymba on a really wide range of tasks.
Okay.
Things like common sense reasoning, question answering, even more specialized things.
Okay.
Like generating code and solving math problems.
So it's not just a one-trick pony.
No, it's not.
They can handle all of these different
Yeah, a variety of challenges.
challenges across different domains.
Precisely. And remember,
Yeah.
they're comparing Hymba to other models,
Right.
often much larger ones,
Yeah.
and still coming out on top.
Okay, I'm looking at this chart again, figure 2.
Okay.
And there are all these acronyms.
Right.
MMLU, ARC, ERC, RCC.
Yeah.
What are these
That's-
benchmarks actually measuring?
MMLU, for example,
Yeah.
stands for Massive Multitask Language,
Mhm.
Understanding.
Okay.
It basically tests how well a model can perform
Uh-huh.
across a wide range of tasks
Okay.
that require understanding and reasoning.
So it's not just about,
It's not just about spitting out words.
right,
It's about showing comprehension.
showing that it gets it.
Yeah, exactly. And then you have the ARC benchmarks,
Uh-huh.
which focus on answering challenging science questions.
So they're really trying to test
They are.
whether it can go beyond.
Yeah, beyond simple pattern recognition.
Right.
And actually demonstrate scientific understanding.
Wow.
Yeah.
And Hymba is holding its own.
It is.
Against the competition.
And not just holding its own.
Yeah.
In many cases, exceeding the performance of much larger models.
Which is remarkable.
It is remarkable.
Now, I keep seeing this acronym, SOTA,
Right.
which I know stands for state of the art.
Yeah.
But what does that actually mean in this context?
It means that at the time of publication,
Uh-huh.
Hymba achieved the best results on these benchmarks.
Okay.
It outperformed all other models in its size category.
So it's setting a new standard for small language models?
Exactly. That's why this paper is generating so much excitement.
Yeah.
It's not just a small improvement.
Right.
It's a significant leap forward.
In terms of both efficiency
Yeah,
and performance.
absolutely.
And that circles back to that idea of democratizing AI.
It does.
If Hymba can keep pushing the boundaries of what's possible
Right.
with small, efficient LLMs,
It could usher in a new era of personalized AI.
where these powerful tools are.
Yeah, where they're available to everyone,
Wow.
regardless of their access to massive computing resources.
That's a really exciting prospect.
It is.
Okay, so we've covered a lot. The hybrid architecture, the meta tokens,
Yeah.
the impressive performance, and the potential for a future where AI is
Right.
more widely available and deeply integrated into our lives.
But we have to remember, this is just one paper.
Right.
It's a glimpse into what might be possible.
Uh-huh.
There's still a lot of work to be done.
Yeah, it really does feel like we're just scratching the surface here.
I think so.
Even with these incredible results,
Yeah.
it sounds like Hymba is really just the beginning.
I think it's a great way to look at it.
Yeah,
We've opened the door to a whole new room full of possibilities.
right. Like, what are you most excited to see?
I'm really interested
Yeah.
to see how this hybrid approach evolves.
Okay.
Can we push it even further?
Yeah.
Can we create even smaller,
Right.
more efficient models
Yeah.
without sacrificing performance?
Right, because if Hymba 1.5b can already outperform models twice its size,
Right.
imagine what like a Hymba 500M or even a Hymba 100M could do.
Yeah, the possibilities are pretty mind-boggling.
That's wild.
And it's not just about shrinking the size.
So-
It's about really understanding the interplay between those attention and SSM heads.
Yeah.
Can we find even more elegant ways to combine their strengths?
Oh, that's interesting.
Can we unlock new capabilities that neither approach could achieve on its own?
Yeah, and what about those meta tokens?
Right.
They seem like such a simple yet powerful idea.
They are.
Like, is there a limit to how much world knowledge we can pack into them? Can we tailor them for specific tasks or even users?
Those are all fantastic questions.
Yeah.
And I think this paper is really just the first step.
Okay.
It's laying the groundwork for a whole new wave of research.
Into these hybrid.
Yeah, into hybrid LLM architectures.
So for our listener out there, what's the takeaway? Why should they care about this deep dive into the world of Hymba?
Because it's a glimpse into the future of AI.
Okay.
It's a sign that AI is becoming more powerful, more efficient, and more accessible.
Than ever before.
Yes, and that has implications for all of us,
Really?
no matter what our interests or expertise might be.
It feels like we're standing at the edge of a new frontier.
I think so.
And Hymba is one of the first explorers venturing out into this uncharted territory.
Exactly. And who knows what incredible discoveries await us out there.
Right.
One thing's for sure, it's going to be an exciting journey.
So, to our listener, keep your eyes peeled and your mind open.
Yes.
The future of AI is unfolding right before us.
That's right.
And it's going to be incredible